Hello and welcome to another LeetCode problem. Today we're going to be doing problem number 1218, longest arithmetic subsequence of a given difference. And so in this problem you're given an integer array r and a difference, and you want to return the length of the longest subsequence in r that every single element's difference is the difference. And so for example, when we have this array here, 1, 2, 3, 4, we have a subsequence here of 1, 2, 3, 4, where the difference between every element is 1. So it needs to be an increasing difference, right? So 2 minus 1 is 1, 3 minus 2 is 1, and so on. So we do have a 4 length subsequence here. Now notice it says you are allowed to delete elements. Something like a sliding window is probably not going to work, and we're going to want to use something like DP or something like that. Okay, now let's look at the second example. So we have 135.7. And here the difference is 1. So actually the difference between everything here is 2. And so the longest subsequence would just be one element, any one of these, and that's going to be length 1. Okay, now let's go to the third example. And let's actually go and take this one. So 1, 5, 7, 8, 5, 3, 4, 2, 1. And they're saying that the answer here is 7, 5, 3, 1, because the difference is -2, so it should go down by 2 every time, which it does, and it's 7, 5, 3, 1. Okay, so we're going to focus on this problem, and we're going to focus on a brute force approach, and then kind of how to simplify it down. So let's start with a brute force approach here, right? So for the brute force approach, what we can do is we can just look for numbers. We can just go backwards, and we're just going to look for the number that we need to look for starting at a number. And so I'm going to show you what that's going to look like. We're going to say result is always going to be at least 1, because, you know, as long as there's one number, there's going to be a subsequence of 1. But regardless. So like, let's say we start at this 1 and we're going backwards. That means if it ends with 1, we have a difference of -2. So if the thing ends with 1, the number before this 1 has to be a 3, right? So we can just look for a 3. So we're going to start at this 1, we're going to look for a 3. We have a 3. Now what are we looking for? We're looking for a 5. We have a 5. Now we're looking for a 7. We have a 7. Now we're looking for a 9. So we're just kind of going backwards, looking for the next number. And then finally, we can just keep track of how many numbers we found that end with this number. You know, how long is our current length subsequence. So here, for example, it would be length 4. So we would return 4 here, right? And we would update this result to 4. Now we do the same thing with 2. So we'd look for a 4. We have a 4. We'd look for a 6. We don't have a 6. So our subsequence here is length 2. And so 2 is less than 4, so we don't need that one. Now we're going to take the 4. We're going to look for a 6. We don't have anything, so we're going to turn 1 there. We have a 3. We are looking for a 5. Let's take that. Now we're looking for a 7. Let's take that. So here's a length of 3. Then for the 5, we're going to look for a 7. So we do have that. We don't have a 9, so that's going to be length 2. For 8, we look for 10. We don't have anything. 7, we look for 9, we don't have anything. 5, we look for 7, we don't have anything. And 1 is the first number. So that's kind of what would be like a brute force, where essentially you know exactly what number to look for. You can just keep iterating. Once you find that number, you look for the next number. You do that for starting at every single number. So that's going to be an n-squared solution. And so it's not going to pass. Now, we're going to use the same kind of logic. But what we can recognize is we don't actually need to look through all these every single time. What we can actually do is we can update the count of the element we have as we go for things we care about. And then we can just look, hey, like what was the count of some other element? So like, for example, for this one, when we look for the 3, if we know that 3 has a subsequence of 3, we can just add a 1, right? And we can do that in linear time. So what we're going to do is we're going to actually keep track for every single number that we encounter, the longest subsequence ending with that number. And now instead of having to look through this whole thing, we can just get that number right away. So like when we're at a 5, we can just say like, okay, if we are at a 5, is a 3 in here? What's the count of a 3? And then whatever the count of the subsequence that ended with 3 is, let's just add 1. And so let's actually show you what that's going to look like. So that's going to be the simplified version of this n-squared. And we're going to make it n time. So now we do need to store something. So we're going to have a dictionary, and we're going to have elements, and we're going to have the length of the longest subsequence ending with that number. So let's show you how that's going to look like, right, with this approach. let's actually get rid of this here. Yeah, let's get rid of this. We're going to make a new result, and we are going to get rid of this as well. Okay. So now let's say we have our result. It's going to be equal to, just make it 0. It doesn't really matter. If there's one element, it's always going to be 1 regardless. Now we're going to have our dictionary. Let's just call that count, maybe C, whatever. Right, okay. So we're going to start at the 1, and we're going to say we have two cases. So case 1, so we're going to write that down actually. Case 1, num minus 1 in our counts. Right? So if that's the case, pretty straightforward, case 1. If num minus 1 is in the counts, that's a pretty straightforward thing, right? I can actually type. So if that's actually in there, what are we doing? Well, it's pretty straightforward. Then you just say count of, yeah, so actually let me make this bigger. So then if it's in there, we just take it and add 1, right? So for example, when we're at this one, if 3 was in here and it has a subsequence of like 3, then this one would have a subsequence of 4, right? Because if you had something with 3 that had 3 numbers, so let's say 3, 5, 7, we can just simply add a 1 at the end, and that would be 4. So if the number minus d is in there, or it's not number minus 1, it's number minus d is in there, then we can just take whatever that is and just add 1, because we can just add that number to the end of whatever sequence that was. And 2, if it's not, then the count will just be 1, right? So then the count of num would equal 1 now, right? So if we're looking for a 3 and it's not in there, then our longest subsequence that ends with 1 is just going to be length 1. So those are our two cases. Let's go through it, and it'll make more sense as we go through it. So we start this one, and we're looking for a 3, right? Because the subsequence that ends with 1 has to have a 3 before the 1. It has to be 3, 1, and then some other stuff here. And so we look for the 3 in our count. We don't have it. That means the subsequence that ends with 1 has to be length 1, right? So we're going to throw that in. So 1 is going to be length 1. Okay, now we're going to go to the 5. And we're going to be looking for, what are we looking for? We're looking for a 3. We don't have a 3. Sorry, actually, for a 5, we're not looking for 3. We're looking for 7, right? Because sequence that ends with a 5 with a d of -2 has to go 7, 5, and then some other stuff before that. So we're looking for a 7. We don't have a 7. Okay, well, that means 5 has to have a subsequence length of 1. Now we're at the 7. For 7, we're looking for a 9. We don't have it. So 7, 1. Now for this 8, we're looking for a 10, right? It has to be 10, 8. Okay, we don't have it. Now for the 5, we are looking for a 7. We do have a 7. And so because we do have a 7, we can just take whatever that is and add 1, right? So if the 7 is a subsequence length of 1, we can always have 7, 5 as our sequence. And if it was length 2, that means we'd have to have like 9, 7, then we could have 5 and so on. So whatever the number is for this 7 is going to go over here, and then we're going to add 1. And so we're going to update our 5 to actually be, instead of 1, we're going to make it 2. Okay, now for the 3, we're looking for a 5. And so we do have a 5, and the count of 5 is 2. So now for the 3, we can actually make it count 3, right? Because if the count of 5 is 2, that means for our sequence with a 5, it has to be 7, 5 to be count 2. And now we're going to add a 3. So that's why it's 7, 5, 3, length 3. Okay, now for the 4, we are looking for a 6. We don't have it. So for the 4, we have count 1 because we don't have a 6. For the 2, we're looking for a 4. We do have it. So it's count 1, which means for the 2, it's going to be a 2 now. So 2 is going to be a 2, right? Because if the count of 4 is 1, that means the subsequence ending with 4 is just 4. And so the subsequence ending with 2 would be 4, 2. Okay, now for the 1, we are looking for a 3. We do have it. The count is 3. That means the longest subsequence that ends with 3 is going to be 7, 5, 3. And now we can just add a 1 at the end, so the length of this would be whatever it was for the 3 plus 1. And so now we're going to update this one. It was a 1, and now it's a 4. So you can kind of see how our values update, right? Like when we checked this one before, the length of our subsequence ending with the 1 was only 1. But if you encounter it again, you're going to have some other elements. And so you're like updating over your old values, which is totally fine. And then finally, we just return the maximum element in this dictionary, which would be 4. So we don't even need to update this result. We can just return the maximum element. That's just O of n, so that costs us nothing. And so that's pretty much our algorithm. So essentially, let's go over it one more time. So we go through this list. If the number minus the difference is in the count, we're going to take that number and add 1, because whatever that number is, all right, whatever that number is, like let's just call it num, we can just add whatever number we have to the end, right? So we'll have like, this will be count, and then it'll be plus, we add this number to the end of the old subsequence, which is going to be count plus 1. Okay, and if it doesn't have it, then we'll just initialize it to 1, because every subsequence can be length 1. Like, so if we're looking for a 1, if we have a 1, we're looking for a 3, we don't have it, then we could always have a subsequence with just a 1. Okay, and so these are literally our only test cases, and then all we have to do is just get the maximum of the list. You could do this in real time, right? Like every time you update this, you could actually get a result as well, but you can also just get the maximum of the keys and lists. Doesn't cost us anything. Like it's still going to be big O of n complexity. All right, so let's actually code it up, and this is going to be one of our, you're going to see this is going to be a laughably small amount of code. So, but let's take a look. So all we have to do is we have a hash map, right? So we're just going to say, let's just say hash map of, what do we want to call this, right? Sequences maybe, or just say counts. Counts equals, we're going to make a dictionary. We don't need to make it a default dict here. Okay, so we're literally going to say for num in R, and then it's just going to be counts num equals, and then I think, so we're going to use the get, so we're going to have a default case. So I'm going to show you what that's going to look like. So I think it's like counts.get of num minus difference. I'll explain this in a second. 0 plus 1. I'll explain this in 1 second. And then we're going to return here the max of counts.key or values. Okay, so I'll explain this. Let me actually make sure it tabs first. Okay. So essentially what we're doing is we are making an empty dictionary, and then we're going through this dictionary, and then we're pretty much saying, let's let the counts of num, so this get function will try to get this index, but if this value does not exist, it will default to 0. So essentially we're saying for a given number, let's try to get the count at the number minus difference, as we talked about before, right, in our drawing. So we're trying to get number minus difference. If it is in there, we're going to use it, right? So we are going to use it. So we're getting that. So like, for example, for 1, we would say, let's try to get the key of 1 minus -2, so 3. If it's not in there, then let's use a default value of 0. And then we're adding 1 to the end, because remember, a subsequence with no elements, with just the 1 element, will be 1. So essentially, we're getting 0 plus 1 if there's nothing else, which would give us a 1. And this num would be the previous number plus 1, right? So we're always adding 1, essentially. So basically, instead of doing this, take that and add 1 and make it 1, we're just saying, let's get this number and let's make this 0. And regardless, we're going to add 1, right? We're going to get this and add 1, or we're going to get 0 and add 1. So it's the same thing. It ends up being the same thing. And then we just go through the values, and then we just get the biggest value there. Okay, so let's take a look. So this actually works. Like I said, it's a laughably small amount of code once you kind of get how it works. Okay, and it did get accepted, and it's reasonably efficient. So. Okay, so let's actually think about the time and space. So for the time, it is O of n, because we are looping through this array 1 time. And for the space, we do have a hash map, and so worst case scenario, imagine every single value is different. So that would be O of n as well, like this 1, 2, 3, 4. You know, if you had 10 to the 5 elements and they would all be, 0 to 10 to the 5 or whatever, you would have to store every single value. But yeah, so hopefully that makes sense to you, how we went from the brute force of n squared solution to the more efficient solution. And yeah, if you like this video, please like it, and I'll see you in the next one. Thanks for watching.